Hi guys, lesson 6 Programming Logic Control PLC. The rule of the Boolean Algebra, we have 12 different rules, so I'm going to explain these rules step by step during this lesson. So this is rule 1, A or A or 0 equal A. Rule number 2, A or 1 equal 1, A and 0 equal 0, A and 1 equal A or A equal A or A bar equal 1, A and A equal 1, A and A bar equal 0, A double bar equal A or A and B equal A or A bar and B equal A or B, and finally we have A or B, A or C equal A or B, C. Okay, let's start with the first one. Rule number 1, A or 0 equal A. Okay, now let's test this case. So you can see here we have OR gate. So I have two cases because A may be equal to 1 or A equal to 0. So this is for case 1 and I use OR gate for case 2. We have always one of the two inputs equal to 0. So here I have 0 and 0. In the first case, I suppose A equal to 1. So 1 and 0, the output is 1. In the second case, I can say A equal to 0. So 0 or 0, the output is 0. So when the input A equal 1, the output equal 1. And when A equals 0, the output equals 0. So we can see the output depends on the value of the input A. So A or 0 equal to A. In rule number 2, A or 1 equal 1. Okay, also we have two cases. The first one, A equal 1 and A equal 0. I have to use two OR gates because I have two cases. This is the first OR gate, this is the second OR gate, and I have two inputs and one output. Always we can see we have one of the two inputs equal to 1. Now I suppose for the first case A equal to 1, so 1 or 1, the output equal to 1. For the second case I suppose A equal to 0, so 0 or 1, the output equal to 1. So we can see the output always equal to 1. Okay, so when A equal 1, the output is 1, and when A equals 0, the output equal to 1. In rule number 3, A and 0 always equal to 0. So here we have AND gate, and also I have two cases. A may be equal to 1 or equal to 0. So I have to plot two ANDs for the two cases. Now I have, you can see, one of the inputs it's always equal to 0. The other input it's A. A may be equal to 1. So 1 and 0, the output equal to 0, or A may be equal to 0. So 0 and 0, the output is 0. So we can see the output it's always equal to 0. So A and 0 equal to 0. Rule number 4, A and 1 equal A. Also, I have two cases, maybe A equal to 1 or A equal to 0, and I have AND gate. Now let's experiment this case. One of the inputs is always equal to 1, and A may be equal to 1 or A equals 0. So when A equal 1, 1 and 1, the output equal to 1. But when A equals 0, 0 and 1, the output is 0. So the output, when the input A equal 1, the output equal 1. When A equals 0, the output equals 0. So this means the output value is depends on the value of A. So A and 1 equal always the value of A. The next case, rule number 5, A or A equal to A. So in this case we have OR gate, and A may be 1 or 0. So I have to use OR gate. and also I have two inputs. The first input is A. The second input is A2. A and A. So when A equal to, for example, when A equal to 1, the second A it's also equal to 1. So here I have 1 and 1, the output equal to 1. And when A equal to 0, the second A is 0 too. So I have 0 or 0, and 0 or 0 equal to 0. So we can see the value of the output it's always equal to the value of A. So A or A equal to A. Okay, so when A equal 1, so 1 or 1, the output equal to 1, and when A equals 0, 0 or 0, the output equal to 0. Now we have rule number 6. In rule number 6, we have A or A bar equal 1. Okay, let's experiment this case. I have two inputs. The first one is A, and the second one is A bar. So let's say the first case A equal to 0. So A bar equal to 1. So here we have 0 or 1. The output equal to 1. And when we have A equal to 1, so A bar equal to 0, and the output 1 or 0, the output equal to 1. So the output always equal to 1. Okay, so A or A bar equal 1. Now we have rule number 7. In rule number 7, A and A equal A. Okay, so we have AND gate. The two inputs are A. So the first case, I suppose A equal to 0. So when A equals 0, the second A equals 0. So I have 0, 0, and the output equal to 0. And when A equal to 1, we have 1 and 1, and the output equal 1. So the value of the output, it depends on the value of A. So when I have 0, 0, the output is 0. When I have 1, 1, the output is 1. So instead of write A and A, we can write just A. Okay, so I can take only one A. The next rule is rule number 8. In rule number 8, we have A and A bar equal 0. Okay, so we have an AND gate, and we have two inputs, A and A bar, and here we have A and A bar. Now I suppose the input A equal to 0 and A bar equal to 1, because A bar is the inverse of A. So I have 0, 1, and the output 0 and 1, the output always equal to 0. And when the input A equal to 1, so A bar equal to 0. So I have 1, 0, and the output equal to 0. So we can see the output always equal to 0. Now we have rule number 9. In rule number 9, A double bar equal to A. To represent A double bar, I plot a double inverter. So when the input equal to A, here I have A bar because of the inverter, then I have A double bar. I suppose the input equal to 0. So A bar, the inverse of 0 is 1. Then I take the inverse again, I have 0. So you can see when the input A equal to 0, the output A double bar equal to 0 too. The next case, I take A equal to 1. Okay, the same figure. But here I suppose A equal to 1. So A bar equal to 0, and A double bar, the inverse of 0 is 1. Also we can see the input A equal 1, and it's the same of the output A double bar, it's equal to 1 too. Now we have rule number 10. So in rule number 10, A or A and B equal to A. Okay, let's prove this one. You can see the left hand side must equal the right hand side. So let's start with the left hand side, a or a and b. Now we can factoring a like a common factor. So we have a, and from the first term we only have 1, and from the second term we have b. Now from rule number 2 we know 1 plus any variable in logic equal to 1. So here 1 or b equal to 1. So the next step we have a and 1. And we know also from the rules the variable, any variable, and 1 equal to a. Okay, depends on the value of a. So if a equals 0, 0 and 1, the result equal to 0. And if a equal to 1, 1 and 1, the result equal to 1. So the result depends on the value of a. Okay, so now we can see the left hand side equal to the right hand side. Also, we can prove this rule by the truth table. So here we have a and b. So I start with 0, 0, and on this represents 0. Then we have 1, then we have 1, 2, and 3. So 0, 1, it's number 1, 1, 0, it's 2, and 1, 1, number 3. The first thing, I have to find a and b. So in this case, we can see a and b. So 0 and 0 equals 0, 0 and 1 equals 0, 1 and 0 equals 0, 1 and 1 equal 1. Then we find a or a and b. So we make ORing between the first column and the third column. So we have 0 or 0, the output equal to 0, 0 or 0 equal to 0, 1 or 0 equal 1, 1 or 1 equal to 1. So now we can see the first column, the column of a, equal the last column, a or a and b. So from this truth table we can prove that the left hand side equal the right hand side. Now we have rule number 11, a or a bar and b equal a or b. So also we have to prove this rule, the left hand side must equal the right hand side. So I'm going to start from the left hand side, a or a bar and b, and this equal. Now let's remember the previous rule, rule number 10, a plus ab equal a. So here we can expand a term to a plus a or b. So here instead of a I can write down a or ab, and then I write the rest of the equation a bar and b. Now I can take b like a common factor from the second and third term. So factoring b out of the second and third term, a or b, then I have a or a bar. And we know a or a bar equal to 1, okay, from the rules. So here we have equal a or b and 1, and b and 1 equal to b from the rules. So we have a or b. So by this way we prove that the left hand side equal the right hand side. Also we can prove rule number 11 from the truth table. So we can see we have a and b. So we make the truth table, then we can find a bar, it's the inverse of a. Then we can find a bar and b. Then we can find a or a bar b, and finally a or b. We can conclude a or a bar b equal to a or b from the truth table. So this means the left hand side equal the right hand side of the equation. Finally we have rule number 12, and now we are going to prove this rule. Okay, so we start from the left hand side. So we can see from the left hand side, first of all we multiply the first term by the second term. So I multiply a by a, I have the first term, then A by C, then I multiply B by A, so I have AB, then I multiply B by C. Then the next step, we know A and A equal to A, only we take one A, and I write down the rest of the equation. After that, I can take A like a common factor from the first term, the second, and the third term. Okay, so from the first term only I have 1, and from the second term I have C, the third term I have B, and then I write down the rest of the equation. Because I have OR gate and 1, the output or the result equal to 1. We can see I have OR gate and 1, so the output always equal 1. We know when we have OR gate and one of the inputs equal to 1, so if the other inputs are A, B, or C, or any value, always the output equal 1, because I have one of the inputs equal 1. So here I have A and A plus C plus B equal to 1, or B and C. And finally, we know A and 1 equal to the value of A or BC. So we prove that the left hand side equal to the right hand side. Thank you for listening. If you like my video, please don't forget subscribe my channel.